Welcome to Chapter 14. Our final chapter in the course has to do with multiple regression. And if you understood the concepts from Chapter 13 on simple linear regression, then this is really a very minor add-on to what you've already know. I already mentioned in the lecture on Chapter 13 some of the points that would be different between simple linear regression and multiple regression. They're very, very similar. So multiple regression has multiple input factors. You still only have the one like say sales, but now you're going to look at say experience of the salesperson, training of the salesperson, time, etc. And the independent variables, how they affect that. When I mentioned about square footage of the house, that was only one factor, and it represented 58%, if you remember from the lecture in Chapter 13. Well, what about the other 42? That's still a lot of error, unexplained error. So in this case, yeah, you've got a whole bunch of slopes, B1, B2, B all the way to whatever. So and the math becomes incredibly tedious and difficult to do by hand. And nobody, even years ago, would want to do it by hand. So the software will calculate it for us as we've got to hopefully, I won't say go so far as to say love, but enjoy the fact that we don't have to do it by hand. So you still have B0, which is the y-intercept, and you have various slopes in this particular case. And we're going to use Excel. It's going to look a lot like before, except because we have multiple slopes. This is with 2 variables. I'm sure you can appreciate how complex it gets with 3 or 4 or 12 variables or whatever. So in this particular case, for the house, for the frozen desserts, we want to determine the pie sales. And we know that the pies are affected by the price. So that would actually be negative. The higher the price, the fewer pies we're going to sell. But also, we're going to determine how much advertising and determine if advertising has an effect on the price of the number of pie sales we have. We've got the data. It looks a lot like before, except now we have the y variable, the pie sales. Our first x variable is the price of the pie, and then we have the advertising. So we have B1 and B2. And by the way, it doesn't matter which order you put it in. That just happens to be the order of the columns, does not matter, except the y-intercept is almost always presented on the left. There's the y variable. So now we have the y-intercept B0. What effect does price have on sales? And we expect that to have a negative. It would be a negative slope. But then the more we spend on advertising, we would expect to sell more pies. Anybody in marketing would know that. So we've got our calculation. I'll show you how to do this. It's the exact same as simple regression. We can see we have the y-intercept of 306. We see that the price is negative. So for every change in the price, it reduces the number of sales by 24.97, about 25. But for every, I believe it was hundreds of thousands of dollars, for every hundreds of thousands of dollars we spend in advertising, it causes the number of pies to be sold to go up by 74. That's what it represents. You can see from before, some of you probably even jumped ahead. Oh, look at the p-values. We want low p-values. The intercept is 0.01993. The price is 0.095. Sorry, 0.095. 0.0379 and advertising 0.01449. We can see we've already got the confidence intervals at 95%. And by the way, you can put in items where it's not 95% if you wanted 98 or 99. You have to be careful because in Excel will give you both confidence intervals. So it'll always give you the 95, but it'll also give you others. But we've focused in on this course on the 95, which is the most common. So in this case, sales will decrease by an average of basically 25 units because it's negative for each dollar increase in the selling price. So if you increase the price of the pies by $1, you can expect to sell 25 less of them than you sold before. You can also, the more money you spend on advertising, it's for every $100 increase in advertising. Sorry, I thought it was 1,000. So if you spend $100 in advertising, you can expect the number of pie sales to go up by 74. So if you increase the price of the pies by $1, we'll say it's minus 25, but you spend $100 on advertising, that'd be plus 74. You would have a net increase of about 49 units, 74 minus the 25. So if you spend $150 on advertising, you can just do the math. If you only increase the price of the pies by 25 cents instead of $1, you just do the math. So in this particular case, so you've actually increased the price by $5.50, but you've also spent $350 on advertising. So you plug the numbers in, do the math. With zero, the other factors, you would have had 306, but your predicted pie sales is almost 429 pies, 428. That's just with price and advertising as your two factors. Now, again, this shows you in Excel, but we're going to use that Excel printout that you saw earlier on a previous slide. It does the confidence intervals and things along that line, so would not necessarily do this manually. Again, R squared, like we dealt with in the house, where the house was 58% of the reason why the change in the price was due to square footage. And if you talk to a realtor, they know this stuff. What's the most important factor? Square footage. Or maybe it's location, maybe it's the neighborhood. Same house in different neighborhoods will sell for different amounts. One of the things I found when I was looking for a rental place was the further you go away from the city core, the center of the city, the less expensive the housing for the same, because you have to travel further. It takes longer to get to work depending on where you work. A lot of people, at least prior to the pandemic, worked in downtown. So in this particular case, the R squared value is 52%. 52.1 of the variation of pie sales explained by the variation in price and advertising. So this is actually weaker than the previous one. So 48% is unexplained. So maybe we need to factor in some other reasons for the pie sales. Maybe the time of year, maybe the competition, a whole bunch of possibilities. And then we adjust it using this formula. We adjust the R squared value to see if the model is significant, but just focus in on R squared. That's what we're doing. Once again, we're going to do a hypothesis test to see not just if B1 is equal to 0, B1 and B2, in this case we only have 2 of them, but if you had more of them, to see we actually want a non-linear relationship. All right, so in this particular case, no linear relationship, it's a horizontal line. And we're going to test to see if any of the slopes is not 0 or not horizontal. We've got our formulas again. We've got our critical values, but we're going to read the p-values. So the p-value of 0.012 reject the null hypothesis, and the overall model is significant. So in this particular case, we have a good model. This model is, if the p-value is high, means the model isn't very good. Because again, we picked, I'll use weather again. Maybe maybe the weather does affect your sales of pies. I don't know. If you're selling them at a county fair, it would, because the number of people that are at the county fair would go up if the weather's good and would go down if the weather's bad. People who sell pies and things like that at county fairs or at the Stampede, when people are running the Calgary Stampede, they know that the weather affects attendance. If you get a lot of bad weather, the attendance is going to go down and you're going to sell less product. So our model is good. You look at the regression of 0.012, it is statistically valid or statistically significant. All right. And you can also do the same thing that we did, by the way, with the slopes. So I just wanted to show you or give you a brief introduction to multiple regression. It's the same thing as single linear regression, with just a little bit more advanced, but the math is way more advanced. But with this Excel printout, we don't have to worry about that.